We're going to discuss how to divide complex numbers, and this is part 1 of the video. In part 1, we're going to first talk about two skills that we need to review that we actually use to divide complex numbers. So we need to know these two things up front before we can divide complex numbers. Hi, in this video we're going to talk about how to divide complex numbers. I call this video as part 1 because before we can divide complex numbers, we have to review two main skills that we actually use while we are dividing complex numbers. The first one, we need to know what do you mean by complex conjugate, or how do you find complex conjugates. Now, conjugate is nothing but the conjugate of A plus B. This is how you find it. The conjugate of A plus B is A minus B. So if one factor is A plus B, the other factor you write it as A minus B with the opposite sign. So A and B are the same. The B will change the sign. Positive B will change the sign to negative B. So that is the only thing we need to remember in conjugates. Now, when it comes to complex conjugates, the only difference is A plus BI. If you have A plus BI as your factor, the conjugate of A plus BI is A minus BI. The imaginary term will change the sign, or the second part, the imaginary part will change the sign. The complex conjugate of A, if you only have a real part, the conjugate is just A. If you only have an imaginary part BI, the conjugate is negative BI. So this is how you can remember what the complex conjugates are. So for example, let me do a few examples here. This is the rule. So let's do a few examples. The conjugate of 2 plus 3i, the conjugate of 2 plus 3i is just 2 minus 3i. So they're conjugates to each other. The conjugate of negative 7, if it's just a real number, you don't change anything. The conjugate of negative 7 is just negative 7. But if you have, what is the conjugate of negative 7i? If it's an imaginary part, the conjugate is positive 7i. So I gave an example for each of these cases. So that's how you find complex conjugates. So in order to divide complex numbers, we will be using this skill, how to find complex conjugate of a given factor. Now, the second thing that we need to review before we can learn this is difference in squares identity. So we have learned in an identity in algebra that goes like this: a squared minus b squared is equal to a plus b times a minus b. Or when you multiply conjugates, you get your answer always as a squared minus b squared. Where does this actually come from? Where does this rule actually come from? It's very simple. You just have to distribute and multiply. I'll just show you right here in a second. So I'm going to do this on the side. So if you have a plus b times a minus b, how do we normally multiply? We distribute and combine terms, right? So I'm going to distribute a times a, which is a squared, a times negative b, which is negative ab, b times a, which is ba, and b times negative b is minus b squared. But we know that positive ba is the same as ab, multiplication, commutative property. So a and b, you can switch them around. Minus b squared. So here negative a squared and positive negative ab and positive ab will cancel, and you will just get a squared minus b squared as your answer. So that's where this rule difference in squares came from. Anyways, we are talking about difference in squares, but we are also talking about complex numbers here. So how we are going to apply this in our division process is this: we will have to find out the product of complex conjugates. A plus bi times a minus bi. What happens when it is a plus bi times a minus bi? So we apply the same rule. According to the rule, we have to square the first term, a squared minus b squared, bi squared here. But this turns out to be, you have your a squared as a squared itself. We know that I is the square root of -1. That's the definition of I. So I squared comes out to be the square root of -1 square, and the square root and square cancels, and we get I squared as 1. So we know that the value of I squared is nothing but 1. So here, this square is for the b and this square is for the I as well. So it becomes b squared, I squared. But we know that I squared is nothing but +1. Sorry, -1. I should have put the negative here. Apologize. -1. So we have your b squared, and then we have I squared is -1. And when you multiply these two negatives, it comes out to be a squared plus b squared. So this is the second part that we have to remember. Let me give you an example for this. So if you have a complex conjugate, I'm going to take the conjugate from here that we talked about. So if you have 2 plus 3i times 2 minus 3i. So when you multiply these complex conjugates, you can apply the same rule here. The final answer will look like this. It will look like a squared plus b squared. So in the place of a, we have 2. In the place of b, we have b is a coefficient. We have 3. So this answer is nothing but 2 squared plus 3 squared, which is 4 plus 9. And 4 plus 9 is 13. So we should be able to know how to multiply conjugates and get their answer like this. One more example. Let's do 6 minus 7i. So if we have 6 minus 7i, we should know that the conjugate is 6 plus 7i. And the product of conjugates is like a plus b, a minus b. And since it's complex conjugate, this will come out to be 6 squared plus 7 squared. So 6 squared is 36, 7 squared is 49, right? 36 and 49, let's just add that. And we get 85 as our answer. So that's it. These are the two skills that we should review before we try to divide complex numbers.